All right, guys, hang on today. Standard normal distribution. You've heard of this before. You've seen some of it before, but going into big time detail today. Really watch, take great notes on this stuff. We're going to be doing this for a while, so really watch closely. Better than usual, even. All right, standard normal distribution. A couple of things you need to know about it, and you know most of this already. It is bell-shaped. Its mean is equal to 0, or mu is 0. The standard deviation is 1. What we're going to do is two things today. We're going to use this to find probabilities corresponding to various regions, and also we're going to go backwards and find z-scores that correspond to areas under the curve. All right, a uniform distribution is when every value is spread evenly over the range of probabilities. I'm going to show you what this looks like in just a second. The graph of uniform distribution results in a rectangular shape. So if it's uniform, it's not a normal curve, it is a rectangular curve, and I'll show you that in just a second. A density curve, big word today. A density curve is the graph of a continuous probability distribution. Now, if you think about it, this is the first time we've done continuous probability. Everything else we've done has been discrete, where we added up all the numbers and we got 1 and probability of 2 or 3 or 4, stuff like that. This is continuous, which means anything is, all numbers are fair game. It must satisfy some properties. First of all, the total area under the curve must equal 1. That's a huge point. And also, every point on the curve has to have a height, bigger than 0. So it never goes below the x-axis, and it's actually always above the x-axis. Area and probability. Because the total area under a density curve is equal to 1, we can use that to help us find probability, and there's a correspondence between the area and probability. So we're going to find area under the curve, which in turn tells us the probability of an event. Using area and probability. Here's the uniform I talked about a minute ago. The uniform looks like a rectangle. It's like this, where all the probabilities are pretty much 0.5. And so it says, find the probability that a randomly selected voltage level is greater than 124.5. And you can see the voltage levels down here. Greater than 1.25 has been shaded for you already right there. So it wants to know what's the probability of randomly selecting a voltage as greater than 124.5. Well, if you look at the shading, 1/4 of the picture shaded is broken into 1, 2, 3, 4 equal parts. Every part has probability of 0.5. So that rectangle has area of height is 0.5, length is 0.5, so length times width is 0.25. So the area is exactly the same as what the probability is, which is what I'm kind of wanting you to see there. So we're going to use area under the curve to find probability. To be honest, we're not going to do hardly any of these. Our main focus is going to be the normal curve, normal distribution, but that is a good example of how it works. All right, here's the standard normal one. This is what you're used to seeing. Look at the mean is in the middle. These are z-scores down here. You've done z-scores before. The numbers you see on the bottom are z-scores, which represent how many standard deviations away you are from the mean. It tells you in the curve the area is 1. So it's a special density curve called the standard normal distribution. And we're going to use it tons the rest of the year. All right, to use it, we got to be able to do z-scores. This says find probabilities when given z-scores. 2 ways to do it. You can find areas using a table, which is what we're going to do tomorrow in class. We're going to spend the whole day using tables because you need to know how to use the tables. And I'll tell you why that's true tomorrow. Technology is also recommended. It says strongly. I'm going to show you some technology you can use on the next day in class. So tomorrow we'll do the tables. The next day we'll do it again with the technology and see which one you like the best. Wonder which one. Here's what the table looks like. It's like, oh my goodness, look at the table. And to be honest, that's just half of it. This is the negative side. If you notice all the numbers over here, the z-scores are all negative. And here's how it kind of works. Let's say you have a z-score of negative 3.12. We're going to go to two decimal places with our z-scores every time. What you do in the column is you find negative 3.1, which is here. And it says negative 3.13. These are hundredths up here, so I'm going to find the 0.03 in that column. So I'm going to kind of come over this way. Gonna go down this way, and that number right there would be the probability. Now, one thing about the z-scores, when it gives you the area, it is the area to the left of the z-score. So this 0.009 that I have circled is the area to the left of that z-score. And think about that z-score is way to the left of your mean because it's negative z-score. So not much probability or not much area to the left of it. Using the table, we just showed you how a little bit. It's designed only for standard normal, which we're going to use the most. Mean is 0, standard deviation 1. It's on 2 pages. It's actually on your website for your book. It's called table A2. One page is for negative z-scores, one's for positive. Each value that you find in the table is the area from the left up to the vertical boundary of the z-score. So every time you see a z-score, it's the area to the left of it. It's a big deal. And when you work with a graph, don't confuse z-scores and areas. Z-scores represent standard deviation. It has nothing to do with how much area it is. Z-score is the distance along the horizontal scale. Area is the region under the curve, which tells you the probability. Number 5, the part of the z-score denoting hundredths is found across the top, which is what I showed you on the last slide. Let's do an example real quick. A bone mineral density test can be helpful in identifying the presence of osteoporosis. The result of this test is commonly measured as a z-score, a lot of tests are, which has a normal distribution with a mean of 0 and standard deviation of 1. A randomly selected adult undergoes a bone density test. What is the probability that the result is less than 1.27? So what I'm going to do is I'm going to go to my table. I'm going to find, well, first draw a picture. That's going to be a big deal. We're going to draw a lot of normal curves today. 1.27 obviously is to the right of the 0. And what I'm looking for, the z-score is going to tell me anyway less than 1.27, which is what I've shaded here. So I basically went up, 1.27, made the bar there, shaded everything to the left of it because that's what my z-score is going to show me. That's what I'm looking for anyway, is what is less than 1.27. So now I just got to go to the table and find the z-score for 1.27, what the probability of that z-score is. So here I go. I found 1.2 in my table, the positive table. Up here I found the point, the hundredths place, which was 7. And I got that area right there, 0.8980. So that's the answer. All right, 0.8980 is the area of the left, which is also the probability of them having a bone density of less than that. Okay, now if they ask me greater than that, which is what they're doing in this one says a selected person has a bone density greater than -1, which would be this pink area right here. Now, issue is if I look up -1.00 in my table, which I'm going to do, it's going to tell me this right here. It's going to tell me 0.1587, but that's not what I want. That always tells you to the left. If you want to the right, here's the complement that we worked on. You do 1 minus that area. So you would get 0.8413. So if you need an area to the right, you have to do 1 minus the area to the left, which is all the area or all the probability that's left. Hope you're seeing how this all comes together with what all we've done, the first part of the year. One more case. A bone density reading between -1 and -2.5 indicates osteopenia. Find the probability that it's between -1 and -2.5. So I drew those down here. -1 looks like that. -2.5 looks like that. So I'll need the area in between. So what I did first is I found the area for z-score -1, which is this. That's the big area from -1 all the way back. -2.5 is much smaller because it's further to the left. So that area, or the probability, is just 0.0062. So to find just the area in between the two, you do the whole area, which is the 0.1587, subtract out the smaller area, which is the part that's not in between, and you get the answer, which is right there, 0.1525. Hope that makes some sense. I found the whole area, subtracted out the part you don't want, and that just leaves you with the part that's in between. Okay, notation, you're going to see a lot of this. Probability of z between A and B, that's what we just did. Z is greater than A, we did one of those. That's where we have to do 1 minus to get the probability. And then Z minus A is the probability that the table actually gives you because it'd be to the left. Okay, now we're going to go backwards, finding z-scores from known areas. First thing we're going to do is draw a bell-shaped curve, identify the region that we need. If it's not a region to the left, we're going to work instead with a known region that is cumulative to the left. We're going to work with the left anyway and kind of do 1 minus that. Number 2, using the cumulative area from the left, locate the closest probability. So we're going to use that table again to find as close a probability as we can to get the z-score. Let me show you an example real quick. Okay, so they asked me what the z-score for area 0.95, or what, the probability is 0.95, or the 95th percentile. What would be my z-score? So what I did is I took the table A2, and I found the closest thing I could to 0.95. And the closest thing I could find is actually halfway between 1.64 and 1.65. So really we're only going to go 2 decimal places, but it really be like 1.645 because it's exactly, when I found it, it was exactly halfway between 1.64 and 1.65. So instead of looking at the columns and rows across the top of the table, you're actually digging through the table looking for 0.95. And I'll show you one of those tomorrow in class also. Using the same reasoning, find the z-scores that separate the bottom 2.5 and the top 2.5. We're going to do this a lot. So the bottom 2.5 is down here, the top 2.5 is up here. And because this is to the left down here, I just looked up 0.025, which is changing 2.5% to a decimal, and got 0.025. And I found that z-score, negative 1.96. Now, I can't do the same method over here, but what I did look up there, because I figured out, okay, if it's 0.025 over here, that leaves to the left, it leaves this much, 0.975. And I just did that by subtracting 1. So I actually looked up 0.975 in the table, and lo and behold, I got positive 1.96. And the reason that happened is one of the properties of the normal curve is that, or the standard normal curve, is it's symmetric. So if you find negative 0.1, if you got 0.025 here and 0.025 here, the z-scores are going to be just opposites of each other because it is symmetric. All right, quick definition. This is a big one. Critical value. We're going to use these a lot. A critical value, so make sure you get this down. A critical value is a z-score separating unlikely values from those that are likely to occur. And we're going to have different definitions for unlikely depending on what problem we're doing. So it's not always going to be just like 0.05 anymore. To be honest, most of the time it's going to be, but problems will define what that is for you, and you got to be able to find the critical values. So when you see this, and you're going to see this z with a little alpha, that's an alpha right there. It denotes the z-score with alpha to its right, not left, but to its right. That's a big deal. So make sure you got that area to the right. Okay, so for example, so let's find the value of the z of the critical value, 0.025. So what I did, what is to the right of 0.025, I looked up 0.025 in the table again, and to the right of 0.025 would be what we found a second ago. Remember, we used the 0.025, and I actually used 0.975 to find, because you got to have this. This is what it's asking. Let me just draw a rough sketch here. It's basically asking you just this area, 0.025, that much area to the right, that much area. So what I had to do is I had to find a z-score for that part right there. So I looked up at my table. I did not look up 0.025. I looked up 0.975 because remember, z-scores give you area to the left or less than that. So that's how I did that one to find the 1.96, which is the same number we had a couple of slides ago. Hope that makes some sense to you. We're going to spend a couple of days doing this because it's that important. Tomorrow, no technology. Sorry about that. Do bring your laptops though, because your tables are on your laptops, so you need to make sure you bring those with you and have them charged up. And the next day I'll show you some technology ways you can do this. So look forward to seeing you. See you. Bye.